Great. Hi, everybody. Happy you're here. Lucas Edas was threatening me to take all my attendees to talk about SQL, but who wants to learn about SQL, right? So who's using Java 8 at the moment? Wow, that's almost everybody, I guess. Maybe even everybody. Great. So you'll be ready to upgrade to Java 9 soon?
Nope, doesn't work.
Nope, doesn't work. Yeah, I heard that before. Good friend of mine said he will update to Java 9. He will do everything to get to value types in Java 10. So maybe that's a good motivation to go to Java 9. But I will hope to give you more reasons to switch eventually. So the title of the talk is Java 9 is coming. And I'll go over that. And then in the end, we can talk a little bit about me. But first, my name is Nicolai. Hi. Great, so Java 9 is coming. When? July, really. That's the latest we have, and it looks like it's going to be the actual release date. So settle in, that's when GA comes out. Okay, a couple of things before I start. There are way too many features in Java 9 to go all of them in detail, right? So this is a showcase, not a tutorial. You're not supposed to get out of this and say, right now I can start using these features. I hope to give you ideas, how they work, and how you might want to use them. And then you can look it up later. And a lot of features I can't even go into. I'll just name them, and then you can see whether it makes sense for you. You can, of course, ask questions during the talk, after the talk. If you're not the kind of guy who speaks out in public, you can Twitter here, and I will maybe see it and answer. And you can follow, if you want, the slides are already online, so you can follow there. Okay, as I said, I have lots to talk about. So these are a couple of things. These are all the things, actually, almost all the things that change in Java 9. So first of all, you get the module system, of course. We have a quick look into that. Then a couple of language changes that we'll go over quickly. Then new and updated APIs. This is where we could spend hours and hours. We're just going to look at a selected few. And then also the last two, which is something that you might not immediately come upon, but which are still nice improvements and worth talking about. So let's start with the module system. Unless, because we can pick and choose a little bit, who of you knows the module system basics? It's almost half. It's actually the worst result. I hope either no one or everybody. Okay, I'll still go over it, but I'll make it quick. So module system has been around for almost 9 years now. It's in planning for almost 9 years now, so we make it this year, hopefully. So let's start with that part, with JShell, the way we see it now. Jars have very few properties. They're just containers for classes, really. So you cannot really define an API. Everything that is public is public. There is no such thing as only within the jar. You cannot name dependencies, and there's no versioning concept. And this is not only academic way to complain about jars. This is actual consequences. Build tools alleviate many of them, but you still might get no class def found error if a jar is missing. And you can never find out until the problem actually occurs on a running system. You have no encapsulation across jars, as I said earlier, and you get nice version conflicts where you end up with 2 versions of Guava on your class path and you don't know which one runs and why and all that kind of stuff. So, in come modules. Modules try to target this and try to alleviate jar hell. And the first thing they do, they get a name and you get to state explicitly which things you depend on. That's awesome. Then you can also define your APIs. You can say these, you can look at it later how this exactly works, but you can say this part of my API is public and the rest will just be within the module. We still don't have a concept, no concept of versions, and so this means we still have version conflicts. So there's really nothing changed there, which I think is sad because that was the most pressing part of JShell, I think. But you get another couple of things, reliable configuration, strong encapsulation. We're going to look at that and a couple of other things that we'll briefly talk about. So modules. Modules means every code is in a module, and also the JDK code was split into modules, into these ones. You can't probably even read that, that's fine. The point is, I'm trying to make is, the JDK was split up and was put into separate parts. You have a module for SQL, you have a module for XML, you have a module for all of the UI, because that could not be separated. So the JDK was split up into modules too. One of them is this one, the java.sql module. All modules are defined with such a file, with the module info Java file. And here you can see the basic structure. Module, and this is the name of the module. Then we require some other modules, and this is a strange keyword in here. We'll touch later on what it means. It uses something, not clear what that means, and then it exports things, and these are packages. It's a little confusing. This is a module name, these are package names. These are also module names. So this is the basic way to define a module. Otherwise, a module is just like a jar, but if you compile this thing and put it into a jar, then it's a module. So there's no new format for your modules. For the Java modules, actually there's a new file format. Great, so now let's talk about two features, reliable configuration and strong encapsulation, and we'll look at each of them in turn. Reliable configuration is very easy. You say, I require these dependencies, and then the module system will make sure that they're there. When you launch, then they have to be there, otherwise you get an error then and then, not later when the system runs for a while. And then there are a couple of other things that it checks, like there should not be any ambiguity. No two modules should say, no two jars should say they are the same module. For example, because one is Guava 18, the other is Guava 14. They both claim to be Guava, and then you can launch. So this kind of ambiguities, or many of them are excluded. You cannot have dependency cycles, at least not defined at compile time. They can occur at runtime, but at compile time you cannot say A depends on B and B on C and C depends on A again. And no split packages, this is a little bit mystic, but what it means is a single package, let's say the Java SQL package, cannot be present in several modules. And this can cause quite a trouble actually when migrating to the module system. So that's the first feature, reliable configuration. Second feature is strong encapsulation, second basic property of the module system. Here we export a couple of packages. And what that means is that only public types in those exported packages are available outside of the module. So when you see public on a type, that doesn't mean, now it means it's visible everywhere. In Java 9, it only means it's visible everywhere in the module. And maybe outside the module, I have to check the module declaration to see what exactly is going on. So the SQL module, exports these three packages. And so result set, for example, which is public, because it is public and because it is exported by the module, you can use it, you can access it, but only if your module reads Java SQL. That means your module must depend on Java SQL. You cannot accidentally use types from modules that you just have coincidentally on the class path. Like today you can, let's say Spring uses OK HTTP and you start using types from OK HTTP even though they don't show up in your Maven POM or something. So this can't happen anymore. If you do not depend on a module, you cannot access its types. This is also where the transitive comes in. It just means that you can also see the types of the module that that module depends on. Details are not that important. I just didn't want to take it out. So this is the actual way it is in the module descriptor. Then we can go into all kinds of features. The different, so strong encapsulation, reliable configuration are basic properties of the module system. But then there are tons of features that we could go into. One thing I picked in particular because I think it's kind of nice are services. Again, with SQL, the SQL module says it uses this type, this actually interface. It says it uses this interface. And then other modules can say, look, I have an implementation for that interface. I provide this interface with the class I have here, with my MySQL driver class. So you can have one API somewhere and then a lot of modules implementing that API, and they all just proclaim, I implement this API. And then the module system acts as a service registry, and then code can just go to the service loader, please load all implementations of the driver class, and then the module system interacts with that, looks at the provides clauses, and it gives you back an iterable. I think it's an iterable of driver. And then you do something. In this case, I throw each over it and put it into a list. You can do whatever, of course. So this is a nice little feature that you can use to decouple your system. There are more features. As I said earlier, one of the most important ones are the first two, which just seen requires and exports, and they were very rudimentary. Right? You require something, so it has to be there. But what if I only want it to be there at compile time and not at runtime? They become optional dependencies. Maybe you only want to export a package to a certain other module. You can use qualified exports. Maybe you want to open a package only for reflection so that Hibernate can use your entities, but you don't want to make your entities public API. You can use open packages and modules for that. So there are a couple of things though how you can tune this requiring and exporting. Then, if everything's a module, you would never need these two things, the unnamed and automatic modules. But in the beginning, well, nothing is a module really, only the JDK stuff, but everything else, everything that you write and everything you depend on in the beginning is in the module. And to make sure that each library developer and each framework maintainer and each application developer can migrate to module systems at their own pace, you have these two features which enable that migration. Layers is an interesting thing. Layers means you can have not only one set of modules running, but you can have different sets of modules in layers running independently of each other. So you can use it. Containers might want to use that to make sure that they don't interact with one another, the different layers of the system. And then another interesting aspect is jailing. That's really cool, actually. With jailing, you create runtime images. So let's say you have a server application, you don't want to have swing in your JDK because then you will make it easier to deploy to Docker or something, it makes the image smaller. With jailing, you can create a JDK, a runtime image, which contains just the modules that you actually need. And you can go further, you can actually include your application modules in that if you want. And then if you run a bin/Java, your application starts. You can do that for images, for Docker images maybe, but you could also do that if you want to, if you develop a desktop application. You can deploy the desktop application to your customer in the form of such a runtime image, and then they just load, and it loads with that Java modules that you have put in there, and they will always run with that version. And then there's the final feature of the module system, and that's it brings much complexity, especially in the beginning. And I guess there will be a lot of people, hopefully me including me, who will live from that. Meaning that trainers and authors and all the kind of people will tell you a lot about the module system, because it does indeed bring a little bit of complexity, but in the end it always comes down to a simple principle of requiring your dependencies and exporting your packages, and from then on everything comes kind of naturally. And there's a good way to get started if you go there. Great, so I'm writing a book with Manning. There's an early access soon, and there's also a course here in April if you want to. Okay, enough with a shameless plug. That was the module system. If you have questions about that, you can ask now or later.
Is it easier than OSGI?
Is it easier than OSGI? That depends on who you ask. I would say the basics are easier than OSGI. It's also less powerful than OSGI because there is no dynamic runtime behavior here. You cannot just unload a module. I would say it's easier, but it still means you have to know a lot of the similar concepts of modules, and you want to think about encapsulation, and you maybe want to think more about services. And I think that's actually a benefit also to OSGI. Much more Java developers will get to know these modular concepts. And I think if they then have to, going to OSGI will be much easier than it is now. So then Java 9 also comes with a couple of small language changes. None of these are even close to what lambdas did to us in Java 8. So they are just very small things, but I think they're still nice and it's worth looking at. So let's start with private interface methods. Before we had them, if you had the two default methods in an interface like here, and you want to share code, here I want to share the sum numbers method, I want to share code, then there's no really a good way to do that. I make it a default method, which means it's public and everybody can use it, and maybe I don't want to. I could put it into some utility class, but it's all kind of clunky, it's not nice, it's not what we're used to when we code with classes. So in Java 9, we just do this. The rest of the class is the same, but here we can just go private, and then we have a private method in the interface. And private methods and interfaces are exactly like their abstract classes. But it means especially that they cannot be overridden. So you cannot have a private method in interface and then have the implementation of the interface change that behavior somehow. That would actually be kind of neat to have something like protected methods in interfaces. But we don't. So the private method is really just there for code sharing within the interface. Then try with resources. When you've been using try with resources a lot, I'm sure you have come up against this one case where you have it's the most regular case. You get something like a connection, you already have it lying around, but then you have to do this thing to use it in the try block. You have to do connection C, like connection Y. Why is C even necessary? And the reason why C is necessary is actually not a technical limitation. It's this block only makes sense if you're sure that you close C. You should not be able to in here assign C to something else, and then what gets closed down here, it's unclear. So the idea is C has to be final. And the easiest way to make that final is to just force you to declare it here, and this is implicitly final. So this is actually the only reason. The only reason is to make sure the developer knows what exactly is going on and to force them to make this final. But in Java 8, we got a new feature, not a new feature, new concept. It's called effectively final, you might remember. Effectively final, sorry? Yeah, I guess that was what I just said. Down here you see again the connection, the try block, and this is where the final is in implicitly. Effectively final. So in Java, in Lambda expressions, you also can't reassign. You can only access things outside of the Lambda expression that are final. But having to declare them as final was seen as clunky, so the idea was to mark them by the compiler as effectively final, meaning they could be final, it wouldn't make a difference, because they're not reassigned anyway. So Java 8 taught this to the compiler and also taught this to developers. Now we have this concept of something is not declared as final, but still it's never changing, really. And now Java 9 uses this property here, and now you can do this. This is all I'm saying, so you don't have to reassign here. Just a small change, but I think will make a couple of these blocks a lot nicer. Okay, diamond operator. I think, and I can't even recall, I didn't code Java a lot, a couple of like 5 years ago or something, so I can't even remember doing it without the diamond operator, without this. Like putting string in here, I can't really recall doing that a lot. But I sometimes see code where it's still in there, where my IDE helpfully complains that this is unnecessary. And this is actually a really nice improvement that you can just leave the string out here, because it's obvious that it must be a list of string, right? So if you use the diamond operator, you just tell Java, look, you'll figure it out, which type you use here. But this never worked here. So here I create in box as a class, and I create the anonymous subclass here. I mean, this doesn't make sense really. Usually there would be some implementation in here. But if I want to do something like this, I want to create an anonymous class, then I have to put in the T here. Why? Again, the why is not that obvious. The reason is that the compiler knows more types than the JVM knows. And sometimes the compiler infers types that cannot be expressed in the JVM. And it's called non-denotable types. And this happens in certain cases, we'll see one later, with anonymous classes. That can happen then. So the idea was, if that can happen, then we're not sure what we're supposed to do, so we just forbid it. We just don't do type inference here. So now a couple of years later, the decision was made, well, why not? After all, we just do the same thing as before, but now we allow it here. We allow it to infer the type here. And if we come up against a non-denotable type, then we get a compiler error. That means that you can now lose the generic parameter here for anonymous classes, and still end up with a smaller code. And in 90% of the cases within the JDK, there was not a non-denotable type. If you want to construct one, you have to do something a little bit crazier, like this. I have to admit, I don't know why it doesn't work. I checked that it indeed doesn't work, but I can't tell you about the exact details. The point is, in this case, the type that is inferred here is non-denotable, so you get a compiler error. And you can see from this construction, this is not something you do regularly. So most cases are like this, and they just work. Second to last, save varargs. Have a look at that code. Does it make sense? So I have a method, first non-null. I give it a couple of arguments. I use the varargs argument here, and then I just stream over the arguments, find the first thing that is not null, and return it. And if all of them are null, I just return the empty optional. So that seems to make sense. But the compiler warns me here, as well as on call sides, it warns me that there's a possible heap pollution from parameterized vararg type. What the hell does it mean? It means that when you box into, like, maybe you know that generics and arrays don't cooperate that well. You cannot actually have an array of T. It must be either an array of string or an array of object or something. And when the Java compiler cannot really tell which T you're using, it actually creates an object array. And if it creates an object array and you rely on the array being actually of type T, then you can end up in trouble. Then you get a heap pollution, meaning at runtime, there is something on the heap that is supposed to be, let's say, a string or string array, but in fact, it's an object array. And when you operate on that, the JVM crashes. Or JVM doesn't crash, but you get a runtime error. So this is a way to build this. The details are not that important. The fact is that I call this method, and here I return I return T array. And when I call this thing, I can put in 2 strings, and I get back, I can put in 3 strings, and what I get back is not a string array, but an object array. So that would be bad. So that's why the compiler warns me. The compiler tells me that this is not safe, and I should do something about it. So either I can have a look at the code and decide that it's unsafe, and I fix it, or in fact it is safe. And the code that I showed you in the beginning was safe because it never relied on the array itself. It just used the types in there. So I can put this on. I can say it's safe varargs. Don't bother me with that warning anymore, but doesn't work in Java 8 because private is not final. private method is not final, because safe var args are only allowed on final methods. That makes sense too, because the warning also appears at call side. So I call a method, and the method is potentially unsafe, so I get a warning here where I call the method. So now I apply the safe var args annotation over there. But let's say the method is overwritten, then maybe another overriding implementation actually does something harmful. So here I think it's all safe, and then it turns out it's not, so we don't want that. So safe var args can only be used if the method cannot be overridden. Which methods can't be? Final methods. Done. Only use it on final methods. So private methods were, as far as I could find out, just just forgotten. So they were just not included in that rule, and Java 9 fixes that. So now you can do, now you can do safe var args on private methods and have one less warning. Who of you works with code that has deprecations in it? Okay. I like my code to be warning free if possible. And there's one thing that's actually a little bit annoying. So see this class. I use the Java type line number input stream, which is deprecated. Do you think this class should throw a deprecation warning? I would say yes. It uses a deprecated type. So I should get a warning somewhere here. Okay, now I do this. Now I'm saying, look, I know I'm using deprecated API, but I myself am deprecated as well. So, don't bother me, bother the guy who calls my code. Unfortunately, I still get a deprecation warning on this import here, which really doesn't make any sense when you think about it, because I'm already saying, like, I know I shouldn't do it, but still get the warning up here. If you use the fully qualified class name here, so you can lose the import, you can just put the Java IO blah 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 down here, then you're good to go, which is stupid, because then the import itself does of course not change what you're really doing. So Java 9 made a very sensible change. Imports of deprecated types don't generate warnings anymore. So if you do things like this, you can now have warning-free code. Woo. Okay, let's look at the clock. Wow, we might make it through everything, because otherwise I'm going to make you choose what you want to look at, but I think we can go through all of these. So we had the module system, which does a lot of things all over the place. The JVM is changed, you have this new module info file, the compiler has changed, everything's changed. Then we looked at the language changes, which just touched a little bit on syntax. Code that didn't used to compile because it was just not syntactic Java now does compile or generates less warnings. Now we can turn to things that are more higher level changes, just regular new APIs, new things you can use, new stuff you can call. First of those are collection factories. If you have static final fields that are just the list of, I don't know, 2 Google URLs or something. And you want to make a list of just these 2 URLs, but you want it to be, you use arrays as list maybe, but if you want to do a map, it's much more complicated. And some people said this would be so awesome, like Python does, for example. Just give me some shorthand notation to say, I want to have a list of these elements and be done with it. Yeah, that's not going to happen. There's a long talk by Stuart Marks where he explains this, and does actually make a lot of sense. I tried to summarize it here. The first reason is language changes are always costly. They always touch on a lot of things, and there's a lot of regression testing involved. So first of all, it must be a sufficient benefit to make those costs worth it. But the second part is actually much more important, because the Java language does not really rely on the collection framework. There is no connection in that direction. Of course, the JDK APIs use the collection framework extensively, but the language itself doesn't know about the collection framework. But if you would do this, then it would have to. Now the compiler or something else in the JVM actually has to know that, oh yeah, if I see this, then I do have to create the Java util array list maybe. And that's not the nicest thing to do, especially because then this only works for the Java util array list. So if you have a different implementation, which is different list implementation, which is also quite awesome and you want to use, you're still stuck with a now much more cumbersome regular way of doing it. So now the native API, which might not be the best in your situation, looks just so much nicer, so you might still want to stick to it. So it gives an unfair advantage to the JDK collections. So yeah, so for these reasons, and I think the second one is the most important one, this is not going to happen. Instead we get just simple factory methods. Since Java 8 included static interface methods, you can have static methods on list and on map and on set too. And these are just, if you're using immutable collections from Java, you will recognize, from Guava, you will recognize this immediately. This is very similar. You just do the class, in this case it's interface of, and then give the types. For map, you can either do this, or if you have too many types, I think there are up to 10 parameters. There exist overloads until up to 10 parameters. If you use more, then you go with this, with the entries. There's also static factory method on, I'm not sure which map entry type. So this way you can create arrays ad hoc. Maps or lists or sets ad hoc. This has a couple of interesting properties. It's not just that you create any list. You don't actually know which list you get, but these lists that you get have a couple of certain properties, and the most important one is they're all immutable. The idea was to use this in, for example, in final fields, which if we would have that, we might call constants. In those areas was the primary use case for these. So the idea was not to seed a list with 2 or 3 elements and later put in more elements. That wouldn't work. These are immutable. But the immutability is not visible in the type system. You still get a list. You still can call add. You just get a runtime error. So if you heard that Java 9 has immutable collections, then this is it. There are collections that are immutable, but the type system doesn't show you that, which would be nice, but I think it's hard to retrofit. So if you use these, be aware they're immutable. They don't take null values, which I hate null. I think that's a good decision. And that's really interesting, the last one. Because, for example, in a set, the iteration order might change from system to system, from run to run, because the hash code is used, which is not stable. But these implementations because they're made for performance, if you have very few elements, they actually use fields to store the elements. And if you store them in the field, you always get the same iteration order. Every system, every Java version, you always get the same iteration order. That would mean that code might accidentally depend on that, or it makes it more likely because there's never a change in this iteration order. So this very interesting decision was made that from one JVM start to the next, you get a different iteration order. So if you go list of ABC within the same, list is always the same iteration order. If you go set of ABC within the same JVM run, you always get the same order, but in the next run you get different orders. This is done by pulling basically a random number, and then when the set of gets the couple of elements, it just reorders them when it writes them into the fields. I think that's a really cool thing to do. Reactive streams. You might have heard about that. The Java 9 goes reactive. It does so, but on a very slow-moving basis, as is not uncommon for Java, to go the defensive route and be sure that things are well thought through before you create a public API. So the idea was not to create a JDK, API that actually does uses reactive streams, but just to provide a common ground for other libraries that do that. So they can implement the same interfaces, and then maybe you have more interaction between different libraries. Who uses reactive streams? Who has done this pub/sub thing before? Very few people. Okay, so the idea is, imagine you're doing something that takes time, like you asking the GitHub API for a couple of projects. You're waiting to get the JSON back. So if you do this now, you maybe want to make a request, and then you get back the whole answer at once, and then you process it. But if you want to use something like reactive streams, you want to make individual calls, and then whenever some call comes back, you process it and do something with it. Or say you want to go over the file system, scan every file for some content. Well, the scanning most likely takes more time than the going over the file system. But the point would be you could maybe tell the file system to give me all the content in that directory and will not wait until everything is decided upon and then give you back a list. But it could give you back a reactive stream, and whenever it finds a new item in the directory, it just pushes it through the stream, and then you can do whatever you want. So there are these 3 things involved. A publisher, which in my example of scanning the file would be the file system scanner. It's the publisher. It publishes new events or new items. It can be subscribed to by a subscriber. A subscriber does something with those elements. It has these 3 interesting methods. It says on next. So the publisher calls on next when something comes. It calls on error when something broke, and it calls on complete when it's done. And the link between the 2 is managed by a subscription, which with the subscriber can request more elements or cancel. So if you want to start subscribing, this is what you want. What you would do. You create a publisher, or you get a publisher maybe from the JDK. You would create a subscriber, and then you call publisher.subscribe with your subscriber. Then the publisher creates a subscription and passes it into the subscriber. Subscriber takes that description and stores it, because a subscription, and stores it because it needs it later. Because from this point on, nothing happens. The idea is that if the subscriber is slow, then the publishers are not allowed to badger the system with more and more data to make the system overflow. The idea is the idea of pushback, that the subscriber can say, now I'm done, give me the next elements. So from this point on, at first nothing happens. Now the subscriber calls request. In this case, requests 10 items. It says, okay, I'm done, whatever I did to initialize, I'm done, give me the first 10 items. And then the publisher at will calls on next a couple of times. Not more than 10, but maybe less if no more elements are there. And this goes on, and then maybe the subscriber managed to process the whole elements and then calls request later again and then again. Or at some point it just decides I'm done. It calls cancel on subscription, or alternatively the publisher may say I'm done. There's an error, or I don't find any more elements, I know I'm done. So then the subscription is cancelled, and both go their separate ways. So now all of this is really nice, but the basic point is when I just said the file system might do this and that, it doesn't. In Java 9, this API is not provided by any, sorry, this API is not used by any API that you might know. You never get a publisher back from any JDK API. These are just the interfaces. There's one class there which implements publisher and subscriber, but other than that, there's no implementation in the JDK. It is meant for other libraries to build on, and maybe in Java 10, when it's clear which would be a good common denominator, then maybe these interfaces evolve, and then you can find them maybe in the JDK API, which I think would make sense for a couple of things. For example, HTTP connections. I forgot to ask the first 2 times. Do you have questions regarding collection factories or the streams? No?
Yeah, well,
yes.
you mentioned that sets have random order.
Yes. So the question was, is the order random, or is it forced, or is it just forced different than last time? No, it's in that sense random. If you call set off and then a couple of elements, then at the first time you do this, one random number is pulled, the seed is created, and that could be the same as the last run. But that would of course be unlikely. Stack walking. Before we go there, if you want to, there's some applications that might want to have a look at the stack. Your method gets called, and the method might want to find out, where do I get called from? There are different scenarios for this. You might want to find leaks, for example, resource leaks with that. This is more done by frameworks most often, but it's still interesting. The best way to do that now is basically to create a throwable and tell the throwable, give me the stack trace. And that's an expensive operation, because it means that Java has to basically stop the world and evaluate the whole stack trace and give you that. And this is cumbersome. First of all, it's not a nice way to do it, and it's also not very fast. So the stack walking API was created to make that faster and easier. So this is a small chain. Main calls 1, 1 calls 2, 2 calls 3, and 3 does this. It gets a stack walker instance, and then it just iterates over it and prints stuff out. So if I run this, I get this. 3 gets printed first because the stack is the topmost element of the stack. Is the last method that got called, and then the method below that was the stack below that was the frame below that was the method that called 3, which is 2. 2 was called by 1, and so you go. Here you go. This is the stack you get out. It's a very simple way to do this. Interesting is, maybe you don't want to get the whole stack. This is where if you want to improve your performance, it's likely that you just want to find maybe the first element that has some properties. Maybe you want to find the first frame, which is a method that does not belong to your framework. So you want to find the first method that is customer code that called you. You don't call for each, you call walk. And what you get here is a stream. So it's a little bit strange. Walk does not return a stream. I will come to that in a moment. Walk gives you a stream. You have to put something in that operates on a stream. So you take this stream, which I called frames, and then you filter. In this case, I look for a method name that contains 1. I take the first element, and then I map that to the line number. Or if this didn't work out because find first returns an optional, or else some unknown line. And if so yeah, the result of all this, the result of this lambda expression, which took the stream and did this small pipeline, the result of that is then returned by walk up here. So this or this, depending on whether I find something, will end up here. And I get the line 11 output. So this is, besides that I get past the stream and then have to do something with it, besides this little bit strange detail, it's just regularly you get a stream of things and then you do something to find the first element. So let me talk about why you put in why you can't just return the stream. The point is basically you have to this API has to fight the different optimizations that the JVM is allowed to do, because the JVM is allowed to reorganize the call stack whenever it wants to improve performance. So if you want to get a stream back, which is evaluated lazily, that's kind of the trick here, that you don't get the whole stack trace at once, but just the elements that you actually want to look at. If you get it back and you want to evaluate it lazily, then it has to be stable. But if the stream is actually returned, then this method is done. This walk method is done, and there's nothing special that the JVM can do. From that moment on, you returned the stream. It's just any Java code that's running. So the JVM would reorganize the stream, the stack, and you would get strange results when operating on the stream. So what it does instead is this walk method does some fancy native stuff, which basically keeps the JVM from reorganizing the stack frames. So as long as you're below this walk method, as long as you're below there, you can do stuff with frames. So if you were to return the stream, for example, if you just say, haha, I'm clever, I just put in the identity function here, I get back the stream outside, and then I do something with the stream, you get invalid state exception. So you have to operate on it in here. There are a couple of options you can take. Reflective frames are not in there by default. Lambda frames are not in there by default. When you call the get instance method, you can just put in these options and then you get something. If you want to get the class reference, we'll see that in a moment, then you put in this one. So what information do you get out of that? For each and walk, both give you stack frames. And stack frames have these information. The class and the method name. You can get, if you put in this option, the class is actually class instance. And bytecode index if you want to deal with that. So these are the things that are easily available. But when you did create a stack trace the old way, you would also create file name and line numbers. And these are apparently expensive operations. You would force this expensive operation every time, even though chances are you don't need it. So now you get a stack frame which offers you the file name as well. And as soon as you call get file name on the stack frame, it internally resolves the stack trace element and then gets the name from there. So doing that is expensive. How expensive? Just a small, very small performance comparison. This is the old way, just create a throwable and look at it, at the exception stack trace. And this is if you take the for each method and then go through through the whole stack, basically create all the stack frames all the stack trace elements, because we go through it, we call get name, get file name on every single one of them, so all the stack frames have to be created. And it makes sense that if it happens lazily and within a stream, then when you do essentially the same thing as before, but with more fancy stuff around it, takes a while longer. So if you just do the same thing as before, get the whole stack and look at all the trace elements, you end up worse than before. Chances are you don't need the trace elements though. So if you do just go through, let's say, what have you available here? Let's say you just go to the method name, then you end up in, let's say, about half the time. And it doesn't make a difference whether you actually want to retain that class instance or if you want to get the class instance. It's just an accessibility check, nothing to do with performance. So what happens if you don't want to go through the whole stream? Because that it's lazy kind of was also a feature. And that pays off too. You have to do a couple of tricks to end up with this exactly. But the point is, if you do those tricks, then you'll see that getting each new stack frame adds a little bit of overhead. So if you know, if you're in a deep stack, because Java occasionally has these, if you end up in a deep stack and just want to go up like 5 methods, then you will end up way cheaper than if you would have done the old way, which evaluates the whole stack. It could be like 50, 100 methods. And then you just use the first 5. You just really use the first 5 and the other one never get evaluated, the other ones. So the stack trace elements are indeed expensive, and the lazy evaluation pays off if you just look at a part of it. And what I just told you, I didn't do the research myself. Arnold Roja, which is an author at SitePoint, He has an article coming out soon, and he will look into that in detail there. I just stole the slides from him. Questions about stack walking? I tend to skip the OS processes because there are a couple of things that I want to show you that are that I think are more interesting. I want to skip this slide, which tells you about a lot of other features that are in there that we don't have time to touch on right now. So, JVM features. Let's do that. Multi-release jars. This is really interesting, I think. So maybe you have the situation sometimes that you want to do something on some Java version and something else on a different Java version. And at the moment, this is kind of cumbersome. You maybe use reflection to find out whether some class is there that you know helps you identify what API is available, and then you have to make sure that these branches don't accidentally come back and you call something that's not supposed to be there in Java 8, but you still call it. Sorry, that's only in Java 8, but you call it in the code that was supposed to only run in Java 7. So if you have these scenarios, then multi-release jars are really going to save you a lot of work, because that makes it really easy. So let's say I have a main class which just creates a version and calls get on it. So it could be any class here. Of course, I decide to name it version. And then I have two implementations of version. And this is really troublesome because getting the IDE to accept this, I didn't make it actually. I just had to compile on the command line then. Because of course, if you have two files with the same class in there, you get compile errors, if it's in the same package at least. So, but if you do this, if IDEs eventually understand this features, you have one branch where you put in the version that's supposed to run on Java 8, another branch where you put in the version that's supposed to run on Java 9. So you have these two versions of the same class. Then what? Then you just compile these two. You make one with main and then the 8 version into out Java 8 maybe, and the other one into out Java 9. And eventually the IDE, so build tools will do that for you, of course. And then you use this new release flag on jar, which is really nice. So if you're not used to it, this is the normal way to create a jar up here. I call the jar command, I say create a file. By the way, this is what I want the file to be called. Everything in the Java 8 folder, put that into, all the classes that are in there, put that into the jar. But now I can say, and release 9, so for the 9 release, also take these classes that are in here. So the jar command takes both classes from the Java 8 and the Java 9 folder. And it looks like this in the end. If you look into the jar, you get this part up here, so just the regular jar. And then down here, you get this, in the meta info order, you get this strange path. You have versions folder, you get a 9 folder because you said release 9. And then you have like similar class path, similar class file folder structure like here, where you end up with the classes down here. And the cool thing about this is, even though Java 7 and 8 don't know about multi-release jars, they don't have to. So this jar would work perfectly on Java 8 because it just looks here. So that part works. And then later on Java 9, if you run it on Java 9 knows about this feature. It looks into here, and there you go. It runs the other code. So indeed, if you run this on Java 8, you get the Java 8 output, and Java 9, you get the Java 9 output, which is kind of neat. That's not so terribly interesting. More things that changed. Version strings, if you call Java minus, if you call the version within Java, the version system property, you get something back that starts with a 9 actually, not along 1 dot something. The command line parameters turn to GNU style. Not all of them. None were actually changed, but there were new alternatives. So you can use minus class minus path, for example, which makes more sense. And a couple of other things. But the last thing I want to touch on is performance, because there were two quite interesting improvements. I think we have time to touch on that, to discuss the first one at least. Strings use char arrays internally, right? So if you have a string, internally you have a char array. And these char arrays make up a huge chunk of any system that's running. It could be parsed XML, JSON responses, whatever. Depending on what system you run, of course there are extremes. I'm sure you have systems with like 2% and other with 98%. But by and large, you end up with like 20 to 30% of the whole heap is occupied just by these char arrays. But the vast majority of these strings actually only ever use Latin 1. So they never use the second part of the char. The char is 2 bytes. Sorry, I missed that. So the char is 2 bytes. But most of them only use 1 byte. So the other byte, like half of this, is by and large thrown away. It's just wasted space. So if we could just take the whole char array thingy and just use the part that we actually need, we could halve this 20 to 30%. So we can end up with 10 to 15% less memory just by this change. And there's a great talk by Alexei Shipilev where he goes into detail about all the pitfalls of implementing this, and it's actually fun to watch. The title is of the talk, why it takes those damn, or the subtitle is why it takes those damn developers a year to implement an easy feature. Let me not go over it, but the point is, now we get a byte array, and if your string is a Latin 1 string indeed, it goes into the byte array and it's save half the space. And if you make a small benchmark like this, which Alexei Shipilev presents in his talk, you get indeed like almost half the garbage only. That makes sense, right? You on loves on this thing you only have garbage that is strings, and if you can save almost half the space, then you end up with like almost half the heap space occupancy. There's another performance improvement for string concatenation, which also improves performance considerably, and more things about performance. If you're interested to learn more about this, you can Google for the Ultimate Guide to Java 9, an article I wrote a while back, and it has links to other articles. So all in all, it's like 10,000 words. It's like this talk, right? It's just one thing after another. So maybe you want, I don't know, read it in steps. But there you can see also the things I left out, I also touched upon there and talked a little bit about. So I already showed you almost this slide. My name is Nicolai, I already said that. You will find me here, I'm blogging here. I'm the editor for SidePoint's Java channel. You can look there for interesting content about Java, and you will find me here on Twitter. Or if you absolutely have to, you can also find me on Google+, maybe. Great, that was that. Thank you. And do you have any further questions? Yes? I can repeat it, it's no problem. Okay.
How does the module system play with OSGI? Is there compatibility problems with OSGI?
How does the module system play with OSGI? That's actually, I can't really answer that because it looked in the beginning like it would not work, but Neil Bartlett wrote, of OSGI fame, wrote a couple of posts about that. And there seem like some deep-seated technical differences that might make this complicated. I would recommend to Google that, or I think I have the article here. I can, if you come up later, I can maybe show it to you. Yeah, that's all I can say. But I think also there's also JBoss module system, and by and large these are supposed to be compatible, but I don't know to exactly which degree. There are also some fundamental difference between how OSGI manages and the module system, particularly when it comes to requiring, because in OSGI you're supposed to require packages, something that the module system does not do at all. More questions? No? Thank you then.